Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class I will teach you some problems on pseudo force. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and Neet exam confidently with a good rank. Now let's start about the class. Here two diagrams are given. This is a wedge or triangular block and a small block of mass m is placed on this plane of the wedge, and a string is attached to the wedge plane. A block of mass capital M is hanging with the string. Now find, here problem is find the mass m so that block of mass m does not slip. This is the question, and these questions are same almost. Here external force is applied by the weight of the block, and this question, an external force is pushed to the triangular block of mass m, and a block of mass small m is placed on the plane. Now what minimum force F applied so that block of mass m does not slip, does not move along the plane or wedge, along the plane of wedge. That is, for what minimum force applied so that whole system will move, so that this block does not slide or slip or move along the plane of the wedge. This question and this question are almost same. Okay, these and these are almost same. And also here sometimes question is asked that what is the normal reaction acting on the block. What is normal reaction acting on block of mass m? What is the normal reaction? So this is the question. Now here F equal to mg, so this and this question are same. Here T and mg, so T equal to external force, T equal to mg, and here external force F is giving. Now to solve this problem, first we find the free body diagram. A force is applied, this is theta, this is small m, capital M. Now when the force is applied, then whole system, this is smooth surface, smooth ground. Now when the force is applied, when this force is applied, whole system moves with an acceleration a. Suppose this acceleration is a, whole system moves with an acceleration a. Pseudo force act on the block m a. Pseudo force act on the block m a. Now different force acting on the block is weight of the block is downward. Now the block slips due to the component of the weight along this direction, which is mg sin theta, and another component of the weight, if we know, if this angle is theta, then this angle is theta. So this angle is theta. If this angle is theta, then this is 90 degrees, so 90 minus theta. Now the whole angle is 90 degree, this is 90 degree, so 90 minus theta is theta. So this angle is theta. Now this is m. Now this part is mg cos theta, so this is mg sin theta, and this is mg cos theta, and this is mg sin theta. Now ma act in this direction. Ma, that is pseudo force. We know that when the system moves in this direction, then pseudo force act in the opposite direction. So pseudo force act in this direction. Now component of this part along this direction will be ma cos theta, because this angle is theta, corresponding angle, this angle is theta, this is corresponding angle, so this part balance this part, so that the block of mass m does not slide along the plane of the wedge. This part balance this part. Now also this is ma, so one component along is this ma cos theta and another component is along this is ma sin theta. So the block slips or slide or move along the plane of the wedge due to this component, but the component of pseudo force along this balance this force. So for condition of no slipping of the condition for no slipping or sliding of block of mass m is what? Now this force equal to this force. This force must be equal to this force, that is ma cos theta equal to mg sin theta, so that a equal to we get g tan theta. So this is the acceleration. Now if the system moves with an acceleration this, then this block does not slide along the wedge of the plane. So now what force should be applied? The force equal to, we know, total mass of the system m plus m into a, that is m plus m into g tan theta. So this is the force required, so this is the minimum force required. This. Now another question is, what is the normal reaction acting on the block of mass m? The normal reaction is along this direction, so this normal reaction must be equal to ma sin theta plus mg cos theta. So normal reaction n equal to ma sin theta plus mg cos theta, that is, what is a equal to g tan theta. So a equal to g tan theta into sin theta plus mg cos theta. So mg tan theta means sin theta by cos theta, so sin square theta by cos theta plus mg cos theta, which is cos theta, mg common, sin square theta plus cos square theta, which is equal to mg by cos theta, which is mg sec theta. So this is the answer. So student can memorize this formula of normal reaction. So this type of problem, what is the normal reaction acting on the block of mass m? This answer is mg sec theta. Now consider this problem. So here, if the free body diagram is m, what is the free body diagram of m? mg act in this direction, tension in this direction, so whole system suppose moves with acceleration a. Now t, whole system moves with an acceleration a in this direction. So what is the equation of motion? Equation of motion of this block is mg minus t equal to ma, we get equation 1, and for this equation we get t equal to m dash plus m into a. So t equal to this, now put t equal to here mg, from this is 1, this is 2, from 1 and 2 we get, from 1 and 2 we get, okay, putting here mg minus t equal to m dash plus m into a equal to ma. Now what is the condition for, so that this block does not slide? This is the condition. In previous problem I have discussed that acceleration will be g tan theta. If the whole system moves with an acceleration a, then this block does not slide along this plane. This block does not slide, as ma pseudo force act in this direction, and the one part of the pseudo force ma cos theta act in this direction. Now weight of the block acts in the direction, and component of the weight along this direction is mg sin theta. So ma cos theta balance mg sin theta, ma cos theta balance mg sin theta. So from this we get a equal to g tan theta. In previous problem I have discussed that if the whole system moves with an acceleration a, then this block does not slide along the plane of the wedge. So condition always we get a equal to g tan theta. Okay, now put here a equal to g tan theta, we get mg g tan theta equal to m into a, suppose a equal to g tan theta, put here. Now we have to find the m. From this we have to find this. Now transfer this, we get mg equal to m dash plus m plus capital M into g tan theta, Now g cancel, so m g cancel. Now m cot theta equal to m dash plus m plus m. Now we have to find m, so m cot theta minus 1 equal to m dash plus m, that is m equal to m dash plus m by cot theta minus 1. So this is the one, this is the answer. If a block is here, suppose this is block m and a small block of mass m is present on this, on the plane of the wedge or triangular block, this is theta. Now if this is a smooth ground surface, now if the block moves in this direction, what is the acceleration of this? So find the acceleration of the whole system. If this surface is smooth, now the block of mass m, this slides along this surface, and this triangular block moves in this direction. So what is the acceleration? What is the acceleration of two blocks? What is the acceleration of two blocks? We have to find what is the acceleration of two blocks. If the wedge moves with an acceleration a, then pseudo force acts in this on the block which is ma. Pseudo force acts on this block which is ma. Wedge moves with an acceleration a0 in this direction, so pseudo force act on the block is ma0. If the block moves with acceleration a0, so pseudo force act in the opposite direction of the block which is ma0. Now draw the free body diagram of each block. This is wedge of mass m, and this is, so now what is the free body diagram? Now this triangular block is placed on the ground, so normal direction n in this direction and weight in this direction, and a reaction force act in this direction, reaction force n, suppose n in this direction, so a normal direction acts in this direction. Now if this angle is theta, we have to, so this angle is theta, so we have to resolve this component along this and this. If this angle is theta, then this angle is theta, so this is 90, so this angle is 90 minus theta. Now this is n, so component of n along this is n cos 90 minus theta, which is equal to n sin theta. Now this n sin theta only acts in this direction, so this force produces the acceleration of the wedge, so that is we get n sin theta equal to m into a0. From this we get n sin theta, because only n sin theta part act in this direction, so n sin theta equal to ma0. Now what is the normal reaction here? What is the different force acting on the block n? Now the weight of the block mg act in this direction, and component of this mg sin theta. Now pseudo force act in this direction. This is pseudo force ma0. So if this angle is theta, then if this angle is theta, so that is this angle is theta, alternate angle. So ma0 part of this part, so component of this component along this direction of this part is m a0 cos theta. Now this force and this force produces the acceleration of the whole block. Now this force and this force, this and this together, these two force produces the acceleration of the block of mass m along this direction. So if the acceleration is a of this block, then ma equal to what? M a0 cos theta plus mg sin theta. Now we get n equal to, from this, m a0 by sin theta. Now here, what is the normal relation of this normal relation? N equal to, we get the mg cos theta act along this direction, mg cos theta acts along this direction, mg cos theta, and also here this is mg, so this is mg, so this part is mg sin theta and this part is mg cos theta, because this angle is theta. Now ma0, so the component of this is ma0 cos theta, and component of this along this is ma0 sin theta, this is ma0 cos theta, this is sin theta. Now n plus ma0 sin theta, ma0 sin theta balance mg cos theta equal to mg cos theta. So if we put n this, we get ma0 by sin theta, plus ma0 sin theta equal to mg cos theta. From this we get a0. Now if we get a0, then we get also a. So from two equation we get, first we get a0. So if from this we get a0, what is a0? A0, if we common a0, then what? M by sin theta plus a0 sin theta. If we common a0, m by sin theta plus m sin theta equal to mg cos theta. So a0 equal to mg cos theta sin theta by m plus m sin square theta. So this is the answer. And what is the acceleration of a? From this equation we get, suppose this is 1, this is 2, and this is 3. So from 3 we get a equal to a0 cos theta plus g sin theta. So put a0 here, we get this sin theta, m plus m sin square theta cos theta plus g sin theta. So if we common take common g sin theta, then we get m cos theta, m cos square theta plus m sin square theta divided by m plus m sin square theta. So first we take LCM, then multiply. So g sin theta common, and g sin theta m plus m divided by m plus m sin square theta. So this is the answer, acceleration of the block A, block of mass m. This is the acceleration of the block of mass m. This is the block mass of, so this is the result. We get, this is the result. Okay, a elevator and an inclined plane is in the elevator. This angle is theta, and the base of the elevator is L length. Now if the elevator is moved with an acceleration a, what is the, this is a block of, this is small block is placed here. This is an elevator, this is a block is placed in the inclined plane, this is the base of the elevator, angle is theta. If the elevator is move upward with an acceleration a, then what is the time taken to slide at the top position, that is time taken to reach from this to this of this block. This is the question. Okay, this is the question. Now here we, when we find the time taken, then we always use the equation of motion. Now what is the equation of motion? A is equal to ut plus half a t square. This, we know that this is the equation of motion. Now what is the length cover along this? The length cover is this. This is s. So what is s? S will be sin theta equal to cos theta equal to base by hypotenuse L by s. So s equal to L by cos theta. This is s. U equal to here 0. Now what is the acceleration? So acceleration is here, acceleration of the block is this. If this is rest, then the acceleration along this will be g sin theta. But actually, if here pseudo force act, because the block, the elevator is moved upward with an acceleration a, so pseudo force act opposite direction, that is ma. Now also mg sin theta acts, also mg act in this direction and ma acts in this direction. So total force along this direction will be, total force along this direction will be ma plus mg sin theta. Now this produces the acceleration of the block, if the acceleration is a dash, suppose m a dash equal to this, so a dash equal to a plus g sin theta. Now the acceleration of the block a dash equal to, we get a plus g sin theta. Now in this equation, if we put s equal to L by cos theta, equal to u here 0 plus half a is acceleration of this body is this a plus g sin theta into t square. So from this we get t square equal to 2l by cos theta into a plus g sin theta, into sin theta root over t equal to root over this. So this is the answer we get. Okay, here suppose here 3 kg block and 2 kg block are given, 3 kg and 2 kg block are suspended by the string over the pulley, and pulley is attached with a spring balance, and the whole elevator is moving upward with an acceleration suppose g by 10. What is the reading of the, here question is what is the reading of spring balance? What is the reading of spring balance? Okay, now this is the question. So if here is attached, so I have explained what is the tension in the Newton's laws of motion. I have explained what is the tension of the string in pulley system. Suppose first we consider fixed pulley. Suppose pulley is fixed, that is elevator is not accelerating. Then what is the tension of the string? So tension of the string we get, suppose first we consider general case. Suppose this is m1, this is m2, and this is acceleration 0. Now what the equation is m1g act in this direction t, m2g t. Tension will be different. Tension will be, so this is the case when pulley is fixed. Now if the pulley is moving upward with an acceleration g by 10, then tension becomes g plus this acceleration. Why? Because pseudo force act in this direction. If pulley is fixed, only weight act in this direction. Now this is accelerating upward, so pseudo force mg by 10 extra added. So just so here tension will be this g plus g by 10. Now the what is the reading of the spring? The reading of the spring, this is t, this is t, so upward this is 2t and this is 2t, so reading of the spring will be 2t. Reading of spring balance will be 2t, which is the answer twice of this. Now if we put m1 m2 3 and 2, we get the result. Okay, 2 into t, that is 2 into 2 m1, 3 into 2 by 3 plus 2 into g plus g by 10 is 11 g by 10. So this is the result. We calculate this. This is the result 3g by 10, 11 g by 10. So this is in Newton. Now next problem is that suppose two blocks of this is mass m, block A and block B of mass 2m is attached by spring whose spring constant is k or stiffness is k. Now the block A is moving towards left with an acceleration a and a force F is applied at the block B. Find acceleration of block B and tension and extension of the string, extension of spring. So what is the question? That is, two blocks are attached with a spring and a force F is applied on the block B. At that instant the block A is accelerating towards left. What is the acceleration of block B now and extension of string? Acceleration of the block A is giving A. Now what is the acceleration of block B? First we draw the free body diagram. Draw the free body diagram. As the block, this block moves towards left, so a pseudo force act in this direction. Then that pseudo force acts in this pseudo, that is the spring will compress towards the block B. So the spring will compress, that is a kx force, spring force kx act in this direction. Now if this is action, then this is reaction, and the block is moving with towards left with an acceleration a, mass m. So from free body diagram, we get kx equal to ma, that is x equal to ma by k. So this is the extension of the spring. Now f plus kx equal to 2m into ab. So ab equal to f plus kx by 2m. Now kx equal to ma. So this is m plus ma by 2m. So this is the answer. Student, this is the end of the class today. To get such type of video and to get more NEET and IIT JEE problems with solution, subscribe my channel. Okay, thank you.